Hello, this video is on lesson 9-1, where in this video we focus on how to solve quadratic equations of ax squared plus bx plus c is equal to 0 by completing the square. Now, we've been working with quadratic equations and on using different methods on how to solve them. One of the very first methods that we used was to solve by factoring, and specifically we used the box method. So if I was going to solve this by using the box method, I basically want to start out by multiplying 6 times -5, and I want to find the factors of -30 that give me positive 13. And so the factors of -30 would be -2 times 15, and so those are the factors that add up to give me positive 13. So we write 2x and -2x and 15x. Next thing that I would do for factoring is basically find factors. What can I take out from 6x squared minus 2x? I can break this down. 2 times 3 times x plus -1 times 2 times x. And so this is 6x squared, and this right here is -2x. Circle whatever they have in common. Well, they both have a 2 and they have an x, 2 and an x, and that is that is the dimension of this red box right here. Alright, let me clean some things up here. Now, since I know the dimension of this red box, this side is 2x, then this must be 3x, because 2x times 3x gives me 6x squared. And everything else follows the same way. Here I have -2x. This has to be -1 because 2x times -1 gives me -2x. And then here I have 5 because 3x times 5 gives me 15x. Now that I have both of my two factors, I use the zero product property. Basically set each factor equal to 0 and then solve for x. This turns out to be that x is equal to -5 over 2. Here I have x minus 1 is equal to 0 and x is equal to 1 over 3. Now, I know I went pretty fast on this because this is a method we've learned before. Basically just summarizing what we need to do to solve the quadratic equation by using factoring. The other method that we recently used was solved by taking the square root. Now, when do we know to take the square root? Notice that this quadratic equation is missing x. Whenever you're missing x, you can easily solve this by taking the square root. And solving this by taking the square root, we add 23 to both sides. We divide by 5, so we get x squared is equal to 23 divided by 5. Take the square root of both sides, so we get x squared is equal to square root of 23 divided by square root of 5. Rationalize the denominator, and you should get the square root of 115 divided by 5. Now, it turns out that there are quadratic equations that taking the square root or factoring is not going to help us solve the equation. Now, in this case, I can't solve this by taking the square root because I do have x here, and so we can already scratch this method out. But what about factoring? Well, let's go ahead and give this a try. If I were to try and solve this by factoring, well, first of all, I multiply 2 times 5 is going to be 10. Now, what are the factors of 10 that add up to give me 12? 2 and 5, 1 and 10. Those are the only factors that I have for 10. And when I add these together, gives me 7 and 11. None of these are 12. And so, as you can see, factoring is not going to help me solve this quadratic equation. So what am I left to do? Well, it turns out that the method that we can solve that quadratic equation is by completing the square. Alright, so let's begin to learn about completing the square. Now, something very important about completing the square is that we're working only with squares. That's pretty intuitive. How do I know if I have a square? Well, the only way you know if you have a square is if the length and the width are exactly the same. In this case, is this a square? Yes. 10 by 10 gives me the square. Alright. Is this a square right here? X plus 1, and then we have 3x plus 5. Is this a square? Are the dimensions exactly the same? Is the length the same as the width? No. This here is a rectangle. Let's take a look at the next one. Is this a square? Yeah. Notice that x plus 6 is the same, has the same length and width. Exactly the same. By the way, let's go ahead and calculate this out. Here we have x squared, 6x, 6x, and 36. Now let's write out the equation for this. This would be x squared plus 12x plus 36. Remember that there were two different ways to find the area of this shape here. We can add the areas, individual areas together, or we could multiply the dimensions. In this case, the dimensions are the same, so I can write it as x plus 6 squared. Now, something very important about looking at this diagram here, notice that the blue areas individually are exactly equal to each other. 6x, this is 6x, and this is also 6x. Why are they equal to each other? Why are they exactly the same? What if I were to do this one right here? Here I would have 3x squared. This would be 5x, 3x, and 5. Notice here the dimensions are the areas are different. The reason these are exactly the same is because this shape is a square and this shape is a rectangle, and so you're going to have different areas for the blue shapes. So this is very important. A square, the blue areas are always going to be the same. And by the way, we can write this, and these two expressions are going to be the same. Now, here is what it's going to set us up to learn by how to complete the square. What if I give you the expression x squared plus 6x? Basically, I'm giving you this information. How do I know what goes there and what would be the other expression? If I gave you that the red box is x squared, and I gave you that these two areas right here, basically this area is this and this area is this, I gave you that both of the areas added together give me 6x. How do I find the area of the green shape? And also, how do I find the expression, the other form of the expression? So think about this for a minute. Pause the video. How do I find the green area first, and then how do I find the other expression for the area? Okay. So remember, something very important about this is that this is a square. And so if this is a square, this area here is exactly the same as this area here. Since I know that both of them added together give me 6x, to find the areas of each rectangle, I basically divide 6x divided by 2. And so each of these is going to be 3x. So this is going to be 3x, and this is going to be 3x. Now, these are exactly the same because this is a square again. It's a square. Now, in order to find the area of this, all I need to do is find the dimensions. X squared, how do I break that up? How do I find the dimensions of this red square right here? Well, it's basically x times x. That's the only way you can split it up. X times x gives me x squared. Here, now I can find the dimension of this. This is 3x. X times what gives me 3x, which is going to be 3 here. And then, since this is a square, I know the dimension here is also 3. So we get x plus 3 and then x plus 3. Now that I know the dimensions, I can find the area of the green shape. It's basically 3 times 3, and so the area of the green shape is going to be 9. And so now I know that this is going to be plus 9. And I also know the other expression for the area, which is going to be x plus 3 squared. So let's just summarize what we did here. We started with x squared and 6x. It gave us that the area of the red square was x squared, and then the two areas combined together were 6x. So basically, what we started with the beginning was this. All we needed to do was find the area of the green shape. Once we found the area of the green shape, can you see how it allowed us to complete the square? And so we found that it was plus 9. And once we found plus 9, we found the other expression for the area, which was x plus 3 squared. That is the essence of completing the square. How do you find this number? How do you find the area of this shape right there to complete the square, and then write the rest of the expression? So, first thing, what you want to do is take a look at this example here. Now, whenever you're given an equation like this, let's just set that equal to 0, you always, the very first thing you want to do is make the coefficient of x squared 1. You always want to make it 1. And so in order to make this 1, we need to divide everything by 4. It's whatever number this is, that's what the number you're dividing by. Alright. So when we divide that by 4, we get x squared plus 8x. Sorry, that is 4x plus 1 is equal to 0. Okay. Now, as you can see, we can now use this diagram, and we can see that x squared is here. 4x is represented by these two areas. By the way, what is the area of each one? Well, since both of these areas are equal, we need to take 4x. What did we do last here? We took the 6x and we divided by 2 in order to get the areas of each one. So we're going to take 4x divided by 2, and each area is going to be 2x. Now, what about this 1? is this 1 represented anywhere in my diagram? No. This 1 is not represented anywhere in my diagram. So what I need to do is I need to move this 1 to the other side. How do I do that? I just subtract 1 from both sides. And so what I have is x squared plus 4x is equal to -1. Now you want to leave some space here because we need to find the area of that green shape. Hence, we need to complete the square. So we can do that by finding dimensions of this shape. By the way, this is always going to be x squared, and so the dimensions are going to be x and x. Here we're going to have 2 because 2 times x gives me 2x, and since this is a square, the dimensions are going to be the same on either side. And so finally I can find the area of the green shape. 2 times 2 is going to be 4. And so that is what completes my square. That's what I'm going to add here, plus 4. Now, since we are adding 4 to the equation, whatever I do to one side, I must do to the other. And so since I added 4 on the left, I have to add 4 on the right. Now, if I were to write the expressions out, this would be x squared plus 4x plus 4. This right here represents the area of the square. But remember, there's another way to write the area of the square. It's basically by using the dimensions. And so x squared plus 4x plus 4 is equal to x plus 2 squared. I could use this or I could use this. And so what I'm going to do next is I'm going to replace 4x squared plus 4x plus 4 with x plus 2 squared. That's what I want to do. And so let's simplify the right hand side. What is -1 plus 4? Well, that's going to be 3. And take a look at this now. So we started with this right here, and now what we have is this expression, this equation. We start with this equation here, and then now we have this equation. Notice that we can solve this equation by taking the square root of both sides. And so if we take the square root of both sides, we're going to have x plus 2 is equal to the square root of 3, plus or minus. And all I have to do now is just subtract 2 from both sides. And so x is equal to plus or minus 3. The square root of 3, is 3 a perfect square? No, it's just going to stay the way it is. Minus 2. Here is my answer. So as you can see, we started with the equation 4x squared plus 16x plus 4, and what we did is we completed the square in order to find our solution, which is plus or minus square root of 3 minus 2. Okay. Now remember when we were looking at all the different methods that we have learned to solve a quadratic equation. First we learned how to factor, then we learned how to take the square root, and then we were stuck here. How do we solve this equation? Well, now we can go ahead and solve it by completing the square. And notice that completing the square uses taking the square root at the very end. So completing the square uses taking the square root at the very end, but first we need to complete the square in order to do that. So let's go ahead and begin with this example here. Okay, the very first thing you want to do is make the coefficient of x squared 1. So whatever number we have here, we have to divide the whole equation. So we have to divide everything by 2. Alright, so that's going to give me x squared plus 6x plus 5 over 2 equals 0. Alright, so let's go ahead and draw our box now. Let's draw our square. Here's my square. Now remember, x squared is always going to go on the top right. Here, my 6x is going to be these two areas. Remember, since this is a square, each of these areas are going to be the same. So we basically take 6x divided by 2, and so each one is going to be 3x. Alright, simple enough. Now, is this 5 over 2 part of my diagram? No. We need to move this 5 over 2 to the other side. So what we're going to have is x squared plus 6x minus 5 over 2, subtract 5 over 2 on both sides, and so we get that is going to be equal to negative 5 over 2. Now you want to leave some space here because you want to complete the square. Alright, so now we can go ahead and complete the square. Again, since this is x squared, the only way you can split that, the dimensions are going to be x and x. Here we're going to have 3 plus 3 because x times 3 gives me 3x. And now I can find this area. It's basically 3 times 3, which is going to be 9. So that is what's going to go here. Whatever I do to one side is I have to do to the other. So plus 9 on the other side. And so as you can see, I completed the square. And this is the expression that I have on the left. Now what I want to do is I want to rewrite this. This represents the area of the square. What's the other way we can write it as? Well, by using the dimensions on the outside. And so that's going to be x plus 3 squared. This is the same as the area of this, same thing. And now I want to go ahead and add negative 5 over 2 plus 9. Use whatever methods you have available. I'm going to turn that 9 into 18 divided by 2. So basically 18 minus 5 is going to be, doing the math, it's going to be 13 over 2, and that is negative 5 over 2 plus 9 is 13 over 2. Okay. So guess what? I completed the square, and this is what I'm left with. Now I can go ahead and take the square root of each side. And so what we have is x plus 3 is equal to the square root of 13 over the square root of 2. Again, since I'm taking the square root of a fraction, I can take the square root of the numerator and the denominator. Just one thing I need to do to solve for x is just basically subtract 3 from both sides. And so I get x is equal to the square root of 13 plus or minus over the square root of 2 minus 3. Again, we need to rationalize the denominator. I don't want that square root in the denominator, so I need to multiply this fraction by square root of 2, both top and bottom. And so x is equal to plus or minus square root of 13 times the square root of 2 is going to be the square root of 26. Just multiplying those two numbers together. Square root of 2 times square root of 2 is going to be 2 minus 3. There we go. This is my answer to this quadratic equation. And by the way, why couldn't we solve this by factoring? Well, it turns out that our final answer had a square root in as part of the answer. So square root of 26 divided by 2 minus 3. There's no way we could have found that trying to find the factors of the initial way we tried to solve that was trying to find the factors of 10. That gave us 12. Factors of 10. It turns out those factors were going to have square roots inside of them, and so which would have been an endless guessing game of trying to find out what those factors were going to be. And so completing the square enables us to use the method of taking the square root of both sides in order to solve for x. Alright, let's do some more examples here. Let's just do one more. Let's go with D. So we have 2x squared minus 4x plus 7 equals 0. Okay, what is the very first thing we want to do? We want to make the coefficient of x squared, because when we draw our box, our square, when we draw our square, this always has to be x squared. Okay, so we need to divide everything by 2. So divide everything by 2. So what we get is x squared minus 2x plus 7 over 2 equals 0. So again, x squared is right here. Negative 2x, remember, these two areas are exactly the same. So we just have to take negative 2x divided by 2, negative 2x divided by 2, and that's going to be negative x. So this is negative x, this is negative x. When you add those together, it gives you negative 2x. And is this part of my diagram in my square? Does that go in my square? Nope. We need to remove it to the other side. So we have to subtract 7 over 2 on both sides. So what we get is x squared minus 2x. You want to leave some space here to complete the square. Is equal to negative 7 divided by 2. Now we can go ahead and complete the square. Find the dimensions. This is always going to be x and x, if you haven't noticed. Here, x times what gives me negative x? Well, it's going to be negative 1. And since this is a square, the dimensions are going to be the same either way. Now I can go ahead and find my my missing area here. Negative 1 times negative 1. Well, that's going to be positive 1, and that completes the square. Whatever you do to one side, you have to do to the other. Now you want to rewrite this. That represents the area of the square. You want to rewrite it using the dimensions on the outside. So this is going to be x minus 1 squared. Here I want to add these together. Use whatever methods are easiest for you. Here I'm just going to turn that 1 into 2 over 2. So that's going to be negative 7 plus 2, which is negative 5 divided by 2. Alright, so completing the square allows us to do this. By the way, we need to be... Well, let's complete this really quick. So what I can do now is just take the square root of both sides. And what I have is x minus 1 is equal to the square root of negative 5 over the square root of 2. Let me go ahead and add 1 to both sides. Add 1 here, add 1 there. And so we get x is equal to the square root of negative 5 divided by the square root of 2 plus 1. Don't forget your plus or minus. First thing I need to do here is rationalize the denominator. So I need to multiply both top and bottom by the square root of 2. So x is equal to plus or minus 2 And here, because this is, I can make this negative 10. So negative 5 times 2 gives me negative 10 plus 1. Now remember, if we have the square root of a negative number, that negative basically becomes, now I hope you remember, it becomes an I. And so the I, that negative goes away and it basically becomes I outside the square root. And so notice that negative is no longer here, it becomes an I, and then that is going to be the solution to my quadratic equation. Alright. Now, one thing I want to do is I want to do this again, but let's not use the diagram. Let's try to let's solve this without using the diagram. And so, well, how would we be able to do that without the diagram? Well, first of all, we need to divide everything by 2. So we get x squared plus 6x plus 5 over 2. Again, notice that we're always moving this to the other side, so we get x squared plus 6x is equal to negative 5 over 2. How would I be able to complete the square without the diagram? Well, notice how we always took the 6, the coefficient of x, and we divided it by 2, which has allowed us to give us 3. Filling out the box, this would be 3x and that would be 3x, right? And then how did we get this number here? Well, we basically multiplied 3 times 3 and that gave us 9. So here, all we need to do is take whatever this number is, divided by 2, and then you square it. Once you do that, that gives you exactly the number that goes inside this area here and that, and whatever it is that goes here. That is always going to work. In this case, it's going to be 9. Plus 9 plus 9. Now let's look at the other examples. Okay, first thing I should do is divide by 4. Now once I divide by 4, I have to take, in order to complete the square, I take this number, 4, and you're always going to divide it by 2, square it, and is that going to give me, oh no. What did I, oh, okay. Yeah, that's exactly, so take 4 divided by 2, which is 2, and then when you square it, you get 4. That is exactly what completed the square, which is what I put here, plus 4 and plus 4. Let's take a look at the last example that we did. Okay, here I'm going to take the negative 2, and you're always going to divide it by 2, and then you're going to square it. What is negative 2 divided by 2? Well, that's going to be negative 1. Negative 1 squared equals positive 1. That's exactly what went here. That's exactly what I added to both sides. And so that is how you do it without the diagram. You take whatever number is, whatever is the coefficient of x, you divide it by 2 and then you square it. So notice that we get 9, we add 9 to both sides. Now how am I supposed to get the other expression without the diagram? It's always going to be whatever's inside the parentheses. What is 6 divided by 2? Notice, well, it's going to be 3. Notice that this is always going to be x, and it's always going to, since it's a square, the dimensions are going to be the same, so you're always going to have it squared. Same thing for the other questions. Notice, how do we know to go from here to here? How do we find this number? Notice we always have x, and this is always squared. To find this number is basically whatever's inside the parentheses. 4 divided by 2, well, that's 2. Bam, that's right there. What about the last example that we did? How do I know to go from here to here? Well, basically, we have x, it's always squared. How do I get this number? Whatever's inside the parentheses here. Negative 2 divided by 2, negative 1. Again, bam, there's my expression. So, looking back at this, whatever's in there, that goes right there. And then basically just add everything here. This was 13 over 2. And then you finally have everything you need in order to take the square root of both sides. And everything else just follows by taking the square root of both sides. So, and our final answer was square root of 26 divided by 2 minus 3 plus or minus. Okay. So, this lesson has been about completing the square. And now you finally have everything you need to solve basically any quadratic equation. You can either factor, you can take the square root if you're missing your x, or if you can't factor, you can always be able to find an answer by completing the square. There you go, ladies and gentlemen. This has been lesson 9-1.